Jessica. I apologize for taking so long to get back to you. I've been going through a whole bunch of examples just to make sure that I understand this properly, and I think that what's happening here with this one is that the information has been given to you in a little bit differently than your previous example, and because the n is so high, because we've got like the 3,112 subjects here. I don't seem to be able to write on this. There we go, the 3,112. They've already grouped the data and done a lot of the calculations for you that you would normally do for a smaller set of data. And so I think that's where the confusion comes from. As I understand it, we are calculating the two sum of squares, and from that we can take everything that we need for our F table, as long as we've got our degrees of freedom, which you and I had already calculated. So the way I look at it is the two things that we're looking for are the sum of squares between and the sum of squares within. And what that means is that we're looking for the differences in the data. The sum of squares is between means we're looking for the differences in the data across the columns. The sum of squares within means that we're looking for like the deviations in the data in the column itself. So just in that category, we're looking at what the deviations are, or the standard deviations there. And the SSB is the deviations between the groups, okay? And so with that in mind, I think that the information that we're being given here has already done a lot of the calculations. And so in trying to do all those calculations the other night, in those huge numbers, I think that's why that was happening to us, because all of this is already laid out for us. So the population mean, the total mean, I guess we don't need the little bar above there, is this value here, the 55.58. That's what they're giving to us. So when we're finding the sum of squares between, what we want to do is compare the means of each of these columns to the population mean. Did I do the wrong mean? Yes, I did. The mean is these numbers. Sorry, the other ones were the variance. Okay. So these are the means here in this first row, and we're comparing them to the mean for the entire population. And so when you're doing your sum of squares between the columns, then we're going to take the means in each case. So like for the first one, 54.9, we're going to find the deviation of that with the population mean and square it. And then we're going to add the next one, 55.8, subtract 55.58, all squared, and so on for the other three columns, okay? That's going to give us our sum of squares between, which we will then divide by the degrees of freedom for that. For the SSW, the sum of squares within, which is in the second row of the F chart, we just need the variances as given in this chart. They've already done all this for us. This is the S squared, and thus the S squared within each column, right? So this is the SSW. And so we just need to add the 38.4 plus 33.6 plus 39.7 plus 27 plus 27 together to get that sum of squares. And so when you're doing your MS column, then in our MS column, what I got for the sum of squares between was 2.178, and we're dividing that by 4 degrees of freedom. And for the sum squares within, we get a total of, where's my total? 165.7, and we're dividing that by the 3107, which is the degrees of freedom for the entire population, right? So taking those values and dividing them will then give us our F statistic. And for my F statistic here, I got 10.21. And I think we had 2 point something when we looked it up in the chart for the 5% significance level for alpha equals 0.05. And so comparing those would mean that we should reject the null because this F statistic is well to the right of the value of 2 point something, which is the F crit. And so this is in the extreme region, which would tell us that there is a significant difference between these 5 columns. So I think that that is what they want us to do for that example. And it might be worth checking that with your TA or somebody else in your class and making sure that that matches with what they've got. And then what I would do is do that over 2 or 3 times. Just start with the question itself and do it again 2 or 3 times just to make sure that you've got a hang of, what goes where and how to calculate all these things, so that if you saw another one similar to this, you would know what to do with it.